begin this next unit on graphing linear equations. We've been graphing. That's what we did yesterday. We graphed using x and y intercepts. There's other ways that we can graph. Today we're going to talk about graphing using an XYT chart. In the next chapter we will talk about graphing equations written in slope-intercept form. The first thing I want to do is practice plotting points. I know you guys can plot points because we did that yesterday when we did our x and y intercepts. But those had zeros, so I want to make sure you're okay with these positive and negative numbers before we go any further. So I've given you like 6 points. I want you to take just a second right now and I want you to plot these points on your graph. So go ahead and do that. Alright, so plotting points shouldn't be a big deal at this point in algebra. We have -2, -2. Do you have a point there? Do you have a point at 0, 4? Right here? Oh, I skipped these up here. That's okay. So this is point D, this is point E. F, I have -2, 3, which is here. Point F. A, I kind of skipped at the beginning. It's 2, 1. B, we have 5, -3. And C is -3, 0. When we're plotting points, that first value of our ordered pair tells us to go right or left. The first value tells us to go right or left. So in point A, the first value was 2. It's a positive number, so we'll go to the right 2 units. 1, 2. 1 tells us how far up or down to go. If it's a positive one, we'll go up. If it was a negative one, we would go down. We went up 1. For part B, or point B, we have 5, -3. So the x value tells us to go right and left along this x-axis. So I went right 5 units, 1, 2, 3, 4, 5. And the y value was negative, so I went down 3. 1, 2, 3. We should be comfortable plotting ordered pairs on a graph. A couple of things we need to talk about. If something is said to be a solution to an equation or solution of an equation, what that means is an ordered pair, written as x, y, that makes the equation true. So if something is a solution, it makes the equation true. A graph of an equation, if you were to graph some equation, that is the set of all points, x, y, that are solutions of the equation. So when we graph a line, any point along that line is a solution to the equation. So what I've given you here in the next example is a graph. It says use the graph to decide whether the point lies on the graph of 4x plus y equals 8. Justify your answer algebraically. So I want to know, let me back up. If a ordered pair is a solution, that means it falls on that line. Does the ordered pair 1, 4 fall along this line? No. Take your pencil and put a dot where 1, 4 is. Take your pencil and put a dot where 1, 4 is. Don't say anything. Just put a dot there. Over 1 and up 4. Right 1 and up 4. Is that point on our line? Yes. Okay. So it should, or it is, a solution. If the point falls on our line, it means it's a solution. It works for that equation. What about 3, 4? Is that a solution? Take your pencil and put a dot where 3, 4 is. Point B is right here at 3, 4. It is definitely not on our line, so it is not a solution. I want to show you algebraically how we could have figured this out. They've given us the graph. They've made it pretty easy for us. I want to see, is 1, 4 a solution? Well, to figure out if it's a solution, substitute it in. We have an x and we have a y value, correct? So let's put 1 into our equation for x and put 4 into our equation for y. That's what I want to do right now. So I'm justifying algebraically. I'm showing and proving that ordered pair really is a solution. So 4 times x, which is 1, plus 4, which is y, equals 8. 4 times 1 is 4. Is 4 plus 4 equal to 8?
Yes.
Yes, it is. 4 plus 4 is
why do we have
8.
a 1 in there?
I put 1 in, at 1 is x, so I put 1 in for x in our equation. Right. I'm just replacing x. So that tells me that part A is definitely a solution. I can see that from the graph, and now I can see from the algebra that it really is a solution. For part B, let's try 3, 4. So remember, 3 is your x value, 4 is your y value. Let's put it into our equation. 4 times 3 plus 4 equals 8. 4 times 3 is 12. Is 12 plus 4 equal to 8?
Yep.
12 plus 4 is 16. That does not equal 8. So what does that tell me about that ordered pair? It's not a solution. Solutions are only points that fall on your line. Solutions are points that make your equation true. And 3 and 4 did not make it true. For the next example, use the graph to decide whether the point lies on the graph of x minus 5, y equals 5. I want you right now to go through, look at those two ordered pairs, do this on your own. I want you to decide, are these ordered pairs solutions to this graph or not? Remember, if they are a solution, then they fall on the line. They are points on your line. If they're not a solution, they are not a point on your line. What about 3, 4? Does that fall on your line? Let's see, Carly, did 3, 4? 3, negative 4 fall on your line? She says no. 3, negative 4 would be here. It's not a point on our line. So that should tell us that it is not a solution. What about 5, 0? Right? Did that fall on your line?
Yes.
It does. 5, 0 is on our line. So part B, or ordered pair in part B, should be a solution. Let's show algebraically that it is or is not a solution. Let's start with part A. I'm going to put 3 in for x and negative 4 in for y. We have 3 minus 2 negative 4 equals 5. Here I have negative 2 times negative 4, which is positive 8. Negative 2 times negative 4 is positive 8. Is 3 plus 8 equal to 5? No. What does 3 plus 8 equal? 11. That does not equal 5. So that tells me right there that part A, or ordered pair in part A, is not a solution. Try part B. Let's put 5 in for x and 0 in for y. Negative 2 times 0 is 0. Is 5 plus 0 equal to 5? It is. So that worked. When I plugged that second order pair in, it worked. It made my equation true. So that tells me that it is a solution. Any questions on how to tell if your ordered pair is a solution or not? Go to the next slide if you would. Example 2 on the top. It says use a table of values to graph the equation 5x equals y minus 2. Alright, so do you know what I mean by a table of values? That's an XYT chart. In order to use an XYT chart, we need to have one variable by itself. I need to have one variable on one side of the equation by itself. Do I have that currently? I don't. I have 5x and I have y minus 2, but neither of them are alone. I could easily make this equation have a variable by itself by adding 2. Please do that with me. Add 2 to both sides of your equation.
So,
Yes.
can you just put the problems there for
And do x and y intercepts? Absolutely, but today we're going to take a different approach and we're going to practice something a little bit different. We're going to use an XYT chart. And absolutely, you could put it in standard form. Now, in order to use an XYT chart, it works a lot easier if you solve for a variable. Now we can pick points. I can pick points for x. I can put anything I want in for x. x. And I want you to pick a variety of numbers. I'm going to start with 0, 1, and negative 1. And when I pick points for x, I can put them in and I can easily solve for y. Question?
Don't you put it in standard form first?
Okay, you guys are thinking about yesterday where we put them in standard form and found their x and y intercepts, correct? That's not what we're doing today. Today we're taking a different approach to graphing. We're using the XY chart. Graphing using XY intercepts is a good option. We can do that. I'm just showing you a different way to do it today. So don't think you have to go to standard form. You don't. There's lots of options. Yesterday was one option, today is another option, and then the next chapter I'm going to show you even a third option for graphing. Let's put 0 in for x. 5 times 0 is 0, and 0 plus 2 is 2. So my y value is 2. So next to 0 in your XYZ chart, put a 2.
Wait, why don't we do plus 2 at the beginning?
I have to solve for one variable. I have to get one variable by itself. So to do that, the easiest way would be to add 2. I could have divided everything by 5, but then that would give me a fraction that I have to worry about. Adding 2 makes it a little bit easier. Let's put 1 in for x. 5 times 1 is 5, and 5 plus 2? 7. Put our third point of negative 1 in for x. 5 times negative 1, negative 5 plus 2? Negative 3. You have 3 points. If you would take a second right now and plot those 3 points on your graph.
I'm confused how you got to y.
Confused how I got what?
The y-intercept.
I don't have a y-intercept. How did I get these values?
Yeah.
Okay, I took x, I picked 3 numbers, any random numbers. I made them easy, 0, 1, negative 1. You can put any numbers you want in. I put 0 in for x in my equation that I've solved for y. You put 0 in there. 5 times 0 is? And 0 plus 2 is 2. I did 5 times 0 plus 2 equals y. I'm just solving this equation. 5 times 0 is 0. And 0 plus 2 is? That's where I got that y is 2. And then I did 1. I put 1 in for x. 5 times 1 is? And 5 plus 2 is? Now try negative 1. 5 times negative 1 is negative 5. Negative 5 plus 2 is negative 3. What did you notice about these points when you plotted them on your graph? You notice anything? Are they just randomly placed? Randy?
They make a straight line.
They make a straight line, and that should always happen if you're graphing a linear function. If they're not in a straight line, you probably did something wrong when you're calculating over here. So take your straight edge, if you would, and draw a line through those 3 points, just like we did yesterday. Remember, your line should go through the points. It's not a segment. It doesn't have endpoints. It just has arrows on the ends to show that it doesn't keep going. Let's do another one. What about this one? Okay, in this one it says use a table of values to graph the equation. I'm going to do an XYT chart. I can pick whatever values of x that I want. It doesn't matter. I typically pick 0, 1, and negative 1 just because they're small numbers and they're easy to plot. They're not usually too outrageous of y values. Several of you had questions on the last example and you said, why did we solve for y? Let me show you why in this example why I solved for y. I'm going to take my equation as it is. And I'm going to put in 0, 1, and negative 1 for x. If I put 0 in for x here, I have 3 times 0 minus 2y equals 6. 3 times 0 is 0 minus 2y equals 6. So really I have negative 2y equals 6. And I would divide by negative 2. Y is negative 3. When I'm putting 0 in for x, aren't I essentially just solving this equation for y here? In our last example, I went ahead and solved for y at the very beginning, so that when I plugged in, it was really easy to calculate. I didn't have to do a lot of work. You can do it this way. You can put it in where you haven't solved for y yet. It's not a big deal. You just have a few more steps to go. Let's put the second value of 1 in. So we have 3 times 1 minus 2y equals 6. 3 times 1 is 3 minus 2y equals 6. Subtract 3 from both sides. Negative 2y equals 3. Divide by negative 2. Y is 3 divided by negative 2 is a negative 1.5. Please write this down, guys. You should be doing this with me.
But doing it the way you do, you don't have to have the y's and x and the
In this problem, I went ahead and solved for y. It just made it easier to calculate.
How do you
You
solve
don't
it?
have to do it that way.
What do you mean
Can we
solve
solve?
y?
we solve on this one too.
Yeah, you can do it that way as well.
I don't understand. What do you mean by solving for y first?
Here in this last example, I added 2 to both sides, so I have solved for y by itself. That's what I mean. You don't have to do it that way. I'm showing you another option here. I'm showing you if you don't solve for y, you just have a few more steps to go. It's not a big deal. You're still going to get to the same answer in the long run. Guys, in here I will show you multiple ways to get to your answer because one way doesn't work all the time. Sometimes you've got to take a different approach to how you're doing problems. Let's put our third value in, which is negative 1. 3. Times negative 1 is negative 3. I'll add 3 to both sides. And divide by negative 2. 9 divided by negative 2 is negative 4.5. Negative 4.5. So take these 3 points, let's plot them on our graph. 0, negative 3. We have 1, negative 1. Wait, I wrote that wrong. Negative 1.5. Negative 3. We have 1, negative 1.5. We have negative 1, 4.5. When you plot these points, should they be in a straight line?
Yes.
100% of the time, if it is a linear equation, we have a linear equation, we'll draw our line through. Someone said, could we have solved this equation for y to make it easier to solve? Absolutely. Let me show you what you could have done. If you had chosen to solve for y, let's take our original equation, which was 3x minus 2y equals 6. If I solve for y, I could have subtracted 3x. If negative 2y equals negative 3x plus 6. Divide by negative 2. So y would be a positive 3 over 2x minus 3. So that when we put our values in, it should get the same value out. So our first value we put into our x, y, t chart was 0, correct? If we had put that in for x down here, 3 over 2 times 0 is 0. And 0 minus 3? 0 minus 3? Negative 3. That's the same thing we got, isn't it? If we had tried 1, 3 over 2 is really 1.5. So 1.5 times 1, 1.5, minus 3. 1.5 minus 3, you guys still have calculators.
Negative 1.5.
Negative 1.5. If we put negative 1 in. (1.5) times negative 1 is negative 1.5 minus 3, negative 4.5, which is the same thing we got up here. I'm just trying to show you multiple ways to do the same problem. Again, there's not one way to do every problem. They're all going to be a little bit different. If you want to go ahead and solve for a variable and then plug in, that's fine. If you'd rather just plug in your x values into your equation as is, that's fine too. Doesn't matter. Alright, I am just about out of time, but I need to do a couple more things with you. Actually, we will save these for tomorrow. I'm going to stop here. We'll save those others for tomorrow. So you guys that are going to be gone tomorrow, I'll make sure I get the video down. A couple more things I'll make sure.
So we have no homework?
Yes, there is homework. There are some problems on a worksheet that I'm going to give you for tonight. We are not doing all of these. If the bell... We're going to do numbers 1 through 9 all. So it says, decide which of the 2 points lie on the graph of the line. We did some examples just like this. You don't need to graph. You can do it algebraically to decide which point falls on the line. Now, 1 might fall, A might, B might. Maybe they both fall on the line. Maybe neither of them fall on the line. So you're going to have to test all the ordered pairs. Okay, you're going to test all the ordered pairs. We are going to do numbers 22 through 27. 22 through 27. Those are your graphing using an XYT chart. And there's 6 graphs on the back that you can use. Okay, 6 graphs on the back.
So cross off 28 through 33?
28 through 33, we're going to talk about a few of those tomorrow, so I'm going to cross them off where you can't see them. You're not doing them tonight.